let's talk about the rational zero theorem. So we got another theorem here that's going to allow us to take one more step in this, journey of solving polynomials. So here's what it says. It says, if a polynomial function written in descending order has integer coefficients, then any rational zero must be of the form plus or minus p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. All right, so let's talk about this. Let's make this relevant to us. So what we started with is completely factorable polynomials. Okay, and then we learned how to factor them, and then we started solving them, which we just go that extra step. We set them equal to 0 and solve. Okay, the next step was to start with a non-factorable polynomial, but we were given some help. We were given a 0, okay, or we were given a factor. Okay, now we're not going to be given anything, and the polynomial may or may not be factorable. Okay, so if it's not factorable, there's got to be a way to find that help we were given before. There's got to be a way to find a 0, and it kind of involves some guessing and checking, and we'll introduce the calculator here too to help us kind of figure out a way to get, narrow down some choices. But this theorem is what's going to allow us to take that unfactorable polynomial and start finding one of its factors or solutions. Okay, so here's what it says. If the polynomial is written in descending order, it has integer coefficients. Okay, so that's what we're looking at right here. The integers, okay, I remember the whole numbers, plus and minus the whole numbers, so 3, 6, -7, those are all integers. Okay, just got to be some number over 1. And then it's in descending order, that's our standard form, it is. Okay, then it's rational zeros, which means our fraction zeros. So that's anything that's 3/4, and it could be positive or negative. It could be 0.25, which really is 1/4. Okay, so any fraction or even a whole number like 2 over 1 is just 2. So any rational zero must be in the form plus or minus p over q. Okay, and then p here is going to be just the factors of the constant term. So this one right here is our constant term. So we take a look at all the factors of 7, and then q is the factors of the leading coefficient. Okay, so this would be our leading coefficient. Okay, so if we look at all the possible pairs of those, p's over q's, factors of the constant term or factors of leading coefficients, somewhere in that list will be this polynomial's rational zeros. Okay, so our list would look something like this. Okay, so the factors of the constant term, which is going to be our p-values, is just 1 and 7. 7's prime. The factors of the leading coefficient, which is going to be our q values, are just 1 and 3. So what we're going to do is we're going to put each p over each q. Okay, so plus or minus p over q is going to go plus and minus. The first p is 1 over 1, so that's this first p over this first q, comma plus or minus 1 over 3, which is the first p over the second q. Okay, comma plus minus 7, then this is the second p over the first q, comma plus minus 7 over 3, which is the second p and second q. So we took each of the p values, put it over each of the q values, and we are guaranteed that if this thing has rational zeros, the numbers in this list, it's either plus or minus 1, plus or minus 1/3, plus or minus 7, or plus or minus 7/3. Okay, so let's take a look at an example here and see if we can't use that information to our advantage. So again, the zeros, again, just quick review there. Zeros are just where the graph across the x-axis. So if this is a parabola, it looks something like this. So, this one might be -1, and this one might be +1. It's in that list. It's got to be if it's a rational zero. Okay.